Hello, good afternoon, everyone. So we'll be starting with the first chapter of Wells today, and that is electric charges and fields. And I'll be first starting with the basic aspect of this chapter. So we'll be talking about what are charges for that matter, and what are the properties of charge, and then we'll dwell into more complex aspect of things. That is, we'll be talking about Coulomb's law, and then the Gauss law, and so on and so forth. Right? Okay, so let us start with what is charge first of all. So charge is a property. So it's a fundamental property of any material because of which it experiences electrical forces. Right. So what do I mean by electrical forces? Let's say you have a positive charge and a positive charge. So what sort of forces do the positive charge feel with each other? There is repulsion between them or attraction, as we know that they are like charges, so there will be repulsion, right? So they will repel each other, and if they are positive and negative charges, like unlike charges, so they will attract each other. Attract in the sense, where will the forces be? So this fellow, if is being attracted by this positive charge, will feel a force in which direction? Attraction means towards it, right? And this object also, if it is getting attracted by the negative charge, its force will also be towards it, right? So that is when the charges are unlike, right? So they attract each other, and like charges, they repel each other. Now, can you tell me what will be the behavior of these two negative charges if they are kept together? So as you can see that these guys are also like charges, so it is but natural for them to also repel each other, right? So they will get repelled as well. I hope it makes sense to you, right? As I alluded to, like charges repel, right? So like charges repel each other, and unlike charges attract each other. So this is the basic of what is charge and what do they do for, so like large like charges repel and unlike charges attract. So this is the very starting point of this chapter, and something that you have already studied also, I suppose. Yes. So let's go ahead. Then we talk about two types of charges. So what are the two types of charges? But of course, there are positive and negative charges, right? Those of what? So from where do the positive and negative charges come from? So what are the fundamental charges that we have under classical physics? So the fundamental charges are those of electrons and protons. And protons have what charge? They have positive charge, while electrons have a negative, right? So this is also something that you must already be knowing. So until we reach to the Coulomb's law part, so until Coulomb's law, it is going to be something that you've already done, and nothing new will be coming across. We'll be studying about insulators, conductors, those sort of things, right? So nothing new, nothing out of blue. Okay, so let us define something called E, right? And let's say, let me define E. So I'm going to assign E a value. Right? So I'm going to give E a number. Let's say E is 1.6 into 10 to the power minus 19 coulomb, right? So I've given it a value. I've given E a value. Let E be this value, right? Now, if you have an electron, write the charge in terms of E. In terms of E, what will be the value of the charge of the electron? Can you tell me what will be the charge of the electron? So as we know that electron has got a negative charge, right? So write the charge in terms of E, it will be negative. negative something, right? Negative how much exactly? We know it is minus 1.6 into 10 raised to power minus 19. And since I already told you that this big value, which I am not going to repeat time and again, I have called it E, right? So in short, I could have also written simply as minus of this object, whereas this object I just defined it as how much? E. So minus E. So basically I'm saying electron charge is how much? Minus E. Right? I hope that makes sense. Okay. So now let's continue. What will be the charge of two electrons? Like one electron charge I showed you is how much? Minus E. My question is, what will be the charge of two electrons? If you have two electrons, what will be the charge? So it should be twice of this, right? So what it could possibly be? It will be like 2 into minus E, which makes it what? Minus E, right? That's the charge if you have two electrons. So what about splitting of electrons? Is splitting of electrons allowed? Can we split electron? Like if you have an electron, it's already a microscopic object, right? So splitting of electron is not part of our syllabus. So we'll not discuss concepts where electrons get split. So splitting of electron is not allowed. Not allowed under our syllabus. So now that you know that we can't allow splitting of charges, my question is, can we produce this charge minus 0.8 into 10 to the minus 19 coulomb? Is it possible to produce this? So you would see that how much is this really equal to if you were to write it? This will, in terms of E, can you tell me what is this equal to in terms of E? Since I already said that, well, E is this value. In terms of E, what is this value? 0.8 into 10 to the minus 19 coulomb. How much is it? And you would see that this is nothing but negative of E by 2. Right? Why negative? I'll explain how I got this. See. I can multiply it by 2 and also can divide it by 2 and then together it can be written as minus 1.6 into 10 raised to the power minus 19 coulomb whole divided by 2. And then you would see that what is this case? This object. What is it? That's nothing but your this fellow E. Okay, my bad. I should not have encircled the entire thing. I should have rather encircled only this part. This part. This is E, right? So how much does it translate to? That comes out to be minus of, and this orange object is nothing but E whole divided by 2. So what we are seeing is that this value which I had given original value minus 0.8 into 10 to the minus 19 coulomb essentially turns out to be minus E by 2. So, and you would see that what is minus E after all, kids? What is this minus E object? This is charge of electron. And if you were to really produce this charge, if you're serious about producing this charge, what would you have to do, kids? You would have to divide that electron charge by 2. And how do you get half of it? You will have to write down here. So to achieve this charge, how much? Minus E by 2. I will have to do what? I'll have to what the electron? I'll have to split the electron. Okay? And is splitting allowed, kids? What did I tell you in the beginning? Splitting is not allowed, right? Not in the classical mechanics. And this is not allowed. Right, so we're not going to split the electron. We're not going to split the protons either, right? Okay, so this is not allowed. So I coming back to the original question. Can you produce this charge, the first charge? This can be produced or not, kids? Hence this charge cannot be produced. This charge of how much? Minus 0.8 into 10 raised to the power cannot be produced, right? So I hope this is clear. Once it is clear, we can take this down. Then we'll move to the second part. And in the meanwhile, you kids think about the second part, which is minus 1 into 10 to the power minus 19 coulomb. Can this be produced or not? Think about it. In the meanwhile, you can take this down. Right? So now let's talk about the second part. Which is minus 1 into 10 raised to the power minus 20. Can this charge be produced? Tell me. So to check that, once since I don't know whether it can be produced or not, what I will do is I'll multiply it with 1.6 and I'll divide it by 1.6. So why I have done that is because you would see that what is this value, kids? How much is this object? What is this value? If you remember it from what we have done, if you recall, this is nothing but the value of value of E at the first place, right? E is coming out to be this value. So we recognize that, oh, this is nothing but E, right? It can be written as minus E by 1.6. And if I ask you what is minus E after all, you would say this is charge of electron divided by 1.6. Now, is this allowed? Can you divide charge of electron by 1.6? You would remember that we can't divide it by two parts also, right? So can we divide it in 1 point by 1.6? This is also no division of electrons are allowed, right? This is also not allowed. Now let's go to the third part, which is minus 1.5 into 10 raised to the power minus 19 coulomb. So what do you think about this? Is this allowed? Again, you see it is short of 1 point. It's not 1.6. It's 1.5, right? So this also is not allowed, because again you can multiply with 1.6 like I did in the last problem. Multiply it with 1.6 and divide it by 1.6. Once you do that, you will recognize this object as your E, and that gives you that this is equal to minus 1.5 divided by 1.6 E, right? So it's like multiplying E with this number, which is 15 by 16. So again you have to 15 by 16 is again a fraction. So basically you are asking me to fraction of what exactly? If you see that this minus E together is what? Charge of electron, COE. I will define here. Let so COE is a short form I am going to use for charge of electron. That's coming out to be charge of electron into 15 by 16. Right. So again, it is like asking an electron uh, to be multiplied with a fraction, right? So a fraction of electron you want. You don't want the full electron. Had it been into one, then that's fine. Then you are just asking for one electron. But here you are asking me a fraction of an electron, which is again allowed or not allowed. That is also again not allowed. Okay? So there we are done with the third part also. Now the next part, take a look at the next part, which is third part. After third part we have a 3.5 part, which is just one extra part I included in between. I call it 3.5. You can call it the fourth part, right? Call it the fourth part to avoid any confusion. This fourth part and this fifth part. So tell me guys, is fourth part allowed? Take a look and tell me. So the way we have dealt with third part, can you kids tell me what will be fourth part? Can you directly tell me what will fourth part turn out to be? So tell me the fourth part. minus 1.7. I hope you can see the way we achieve COE into 15 by 16. What will be achieved for the fourth part? It will be COE into how much? 17 by 16. Can you all see that? It will turn out to be 17 by 16. Right? And this is again fraction. Again, that what something we don't want, right? We don't want fraction, and that's precisely what it is coming out to be. This is fraction of an electronic charge, which is not allowed. Now comes the fifth part. So fifth part, let's see how many of you can guess what will be the situation in fifth part. Fifth part says minus 4.8 into 10 raised to power minus 19 coulomb. Now this is possible or not? Let me see if you kids can figure this out. Take your time and tell me what will be this. Minus 4.8 into 10 so minus 19 coulomb. Tell me. What will be this? Can you see that this is a multiple? Multiple of what? Minus 4.8 it is. So it is how many times E? So I hope you can see that this is nothing but 3 times negative 1.6 to 10 raised to power minus 9. Okay, that's what it is turning out to be. And how much is this object? Well, this is nothing but our COE, charge of electron. That comes out to be 3 times charge of electron. Okay, is this possible or not? Yes, it's very much possible. How it is possible? Tell me what you have to do for this. If you want 3 times charge of electron, what will you have to do? To get 3 times charge of electron, all you have to do is get how many electron skips? To get 3 times charge of electron, all you have to do is get 3 electrons, right? If you get 3 electrons, it's like writing 3 times minus. You know, if you get 3 electrons, so you would essentially end up getting this charge, right? So is this possible? Is this possible? Answer is a resounding yes. This is very much possible. Right? And what do we need, kids, for this to be a possibility? All we need are three charges. Which charges to be precise? 3 electrons. That's it. And we can very well get 3 electrons, right? No big deal. So that way you decide that which charges are possible and which charges are not possible. Now this process is quite flimsy. There is no system here, right? So what we'll be doing now is we'll be trying to figure out a system, a mathematical procedure, which could tell us with mathematical precision and certainty whether whether a given charge, is it possible to have it or not? Is it possible for it to exist in nature under classical physics or not? Okay. So let us talk about that in the next slide. And speaking of possibility, so what charges are possible, kids? List of possibilities. Now that we have done so many cases, what do you think? What do you see? What charges are possible? So we saw that is minus E possible? Yes. Why it is possible? Why is minus E possible? Well, write down. This is possible as it just needs one electron, right? You get one electron and you get discharge, no biggie. What about minus 2e? This is also possible. We very much saw this, didn't we? The last slide, if you remember. Oh, minus 2, yeah. So minus 2e, I think we saw it, right? Where did we see it? Here, here, you see, minus 2e. It was very much possible, kids. You know, very much possible. What do you need? All you need is a bunch of 2 electrons. So this is possible. Yes, very much. We saw it. What about minus 3, kids? Is this possible? Yes, because this is again what? There's 3 electrons. And where did we see? Just just in the last page we saw it, didn't we? That is where we saw it. You see, 3 times minus 3. So minus 3 is also very much possible. Minus 3 is also very much possible, right? Okay, so what is the grand picture with the conclusion we can draw out of all these examples? What do you say about minus 4e? Is this possible, kids? Minus 4e. Very much, right? How much? How many? What do you need for this? All you need is 4 electrons. No biggie. So in general, what we can write? What are possible? So in general, I see that we can have minus. We can have minus. Sign can be there. It can be there, and a number can be there. Specifically, an integer can be there. So you have minus n. N is an integer, and you can have a e minus n, and this is possible. In general, I can write minus ne is possible, right? I hope all of you all are convinced and could appreciate the fact that minus ne is possible. You know? And how are we getting these negative charges, kids? So you have seen that all my examples are but about negative charges. So how am I getting negative charges? So what are we doing to get negative charges, kids? We are adding electrons or we are removing electrons? What are we essentially doing? How do you get negative charge? You have to remove electron or you give electron. Let's say there's an object. Object. So let us say that I have an object, right? Let's say I have a potato. Potato doesn't have any charge by itself, so it is neutral object. Can you see this color? Yeah. So potato is a neutral object, right? Now, if I'm like, okay, today I want a negative potato. In that sense, I want a negatively charged potato. So what do I do? Tell me. The easiest part is to just buy some electrons and throw it on it, right? So if you buy some electrons, throw it on it, the electrons, let's say, stick to the potato, and potato will get what charge? We get negative charge, right? So coming back to the original question, which was to get negative charges, we simply have to dash electrons. Add or remove, but of course add electrons, because electrons will get negative charges with themselves, thereby giving negative charge to the body of interest, right? Now that part is absolutely clear to you, how we get negative charges. Why I want that to be clear, so that now we can understand in the next slide that how we produce positive charges, right? So let's go ahead. You can take this down, and then we'll move to how do we produce positive charge. Take this down, think about it. Any doubts? Let me know. Then we'll go ahead. So let's go to the next topic now. And before we get into positive charges, let us solve this problem. Let's answer to these questions. Very basic, fundamental questions that will help you understand how charges are produced. Okay, so see, let us say you have your atom. So this is your nucleus, and around it you have a couple of electrons running around the orbit. Suppose there are two different orbits. I've just drawn it in the same orbit. So you could have same orbit also. But the question is, what is the net charge of this atom? This is an atom. So if I ask you the net charge, what you have to see is that you have two protons and you have two electrons. So what will be the net charge case? Tell me. See, your n is neutron, right? Which has got no charge. That is that is useless. So in determining charge, my neutrons are useless, right? So if neutrons are useless in determining charge because they don't have their any charge of their own, so what is the total charge of this object? We'll see that you have got two protons, you know. So two protons have how much charge, kids? Let's see. Two protons will have how much charge? I'll write down. These two fellow will contribute and they're positive charge, right? So see, one proton charge will be how much? Plus 1.6 into 10 raised to the power minus 19 coulomb. So can you say that it is plus? How much is this value again? You remember this value is E plus E. So one proton charge is plus E. Okay. So two protons will have how many charge kids? One proton has got plus E. Two protons will have 2 each. Correct? And what about two electrons will have how much charge? Shall we? This fellow will say I have minus E charge. This fellow will say I also have minus E charge. And neutrons, as I said, are useless. They have got no charge, right? So I've made some Should have been more spacing if I will try to accommodate here itself. So let's talk about total charge. What is the total charge of the atom? It will be, because of the protons, it will be 2e. Agree? Because of the electrons, how much will it be? Electron minus e because of one electron. Minus e because of one electron and minus e because of another electron. So how much total? Minus e, minus e. And our neutrons are useless. So these guys are going to give us no charge. So plus 0. So what does the total charge come out to be? Total, in total it comes out to be how much? 0. No charge. So net charge is 0. This atom's net charge is 0. And so we have a second atom here. Second atom. Now think about what will be the net charge of the second atom. Think about it. Did not find out? So as you can see, neutrons are useless, no charge. Protons will have 2e. And electron, guys, there is only one electron. Where's the electron? Other electron has gone already, right? So this fellow will only provide minus e charge. So what is the net charge of the atom? And that is, what has happened to that electron? You know, we didn't like that electron. So we said, the second electron, you get lost from here. I don't want to see you anymore. So that poor fellow has been removed. There is no electron here, kids. There is no electron here. We removed the electron, right? We removed the electron. So net charge comes out to be how much? Net charge comes out to be, let's see, our protons provide 2e, while our electron, only one poor electron is there, it provides minus e, right? And you would, what about the neutron, kids? You know, neutron is a poor guy, doesn't have any charge, so that's good. What is it? So all total also B. It all comes out to E. So net charge is E. And plus E at that, right? Plus E. Oh, great. We ended up generating what charge, kids? We ended up generating a positive charge, right? Earlier we ended up generating what charge? Earlier we ended up generating a negative charge, right? Negative. How a negative charge generated? By adding electron. Adding electron gives negative charge. And at the same time, if I ask you to get positive charge, we have to rather do what, kids? We have to add electron or remove electron. What did we do here? Here, this electron we did not like. I removed it, right? So what do? We'd rather remove electron. Then you would say that we can add proton also to make it positive, right? But we will not do that. To get positive charge, we'd rather remove electron than add proton. Proton has positive charge, but I'm not going to add more protons. Now, it brings us to the next question. Why don't we instead add proton? See, protons have what charge again? Protons have positive charge, right? So if I add a proton which has already got positive charge, it's very easily I can make positive charges, right? Just by adding proton. Like if you remember here, to make negative charges, what did I add? Electron. So you would ask me, why not to add proton directly to the potato and make it positive charge? But we don't do that. So that's why I've written, to get positive charge, we would rather remove electron than add proton. We will not add proton. And why is that? Why don't we want to add protons instead of why don't we want to add protons, and why are we going to remove electrons instead? What is the reason for that? Can anyone think and tell me? Why to get positive charges we generally want to remove electron rather than adding proton? See, adding proton will also solve our problem, right? Won't it? Let me explain you. If you want positive charge and you have potato, right? Positive neutral potato. We want to make it positively charged. So my proposal is, why don't we add protons? Add protons, but actually we don't do that. Why don't we do that is the question. Why don't we add protons? Because adding proton will make it positive, right? And our purpose is fulfilled. But we won't do that. Why? So let's check why. Now if you see that this is your nucleus and you have got protons, neutron, and a bunch of free electrons running around the surface. Now kids, protons live inside the nucleus, right? Whereas electrons don't live inside the nucleus. So if you were to add protons, you'll have to get protons from somewhere, and where will you get it from? From the nucleus. You'll have to get proton from the nucleus, right? And to remove proton from the nucleus will start what sort of reaction? If you're basically trying to disturb the nucleus, right? If you try to disturb the nucleus, what sort of reaction are you moving towards? That is called nuclear reaction, right? So if you try to play with protons who live inside the nucleus, you are basically trying to start a nuclear reaction, right? And which is not allowed. That would be very dangerous and an extremely difficult thing to do, right? So because protons live inside the nucleus, we don't want to play with protons, and that's why we are happily either adding electrons or removing electrons, because electrons do not live inside the nucleus. Okay? And the reason for that, why, I'll write it here. The reason is because we do because protons live inside the nucleus, and we don't want to casually start a nuclear reaction just for giving an object positive charge or negative charge. That's why we'll stay away from protons, and we'll rather deal with what? Electrons. So if you want positive charge, we'll revise what we did today. If you want to give, or if you want to get positive charge, what we'll do, kids? We will remove electrons and not add protons, right? And if you want, that is how you get positive charge. For positive charge, you have to remove electrons. And for negative charge, what you will do? That's very simple. You just add electrons. So that is the summary of what we have done today. And in the next lecture, we'll be talking about what sort of positive charges can we possibly have. Like we did speak of what sort of negative charges can we possibly have. Likewise, I'll be talking about what sort of positive charges we can possibly have. And we'll try to make a general formula about the kind of charges that we can have, right? And that formula will help us determine with mathematical certainty and mathematical precision as to what sort of charges are allowed and what sort of charges are not allowed, what charges we can have, what charges we can not have. And then we'll come down finally to a property of charges which is called quantization of charge, which we'll study in the impending classes. So hope you can revise what we have done today so that we can build upon this in the coming lectures. Okay? That be all for today.